We are starting now the paper 2021 May June 9709 oblique 32. The total timings for this paper is 1 hour 50 minutes. The marks is 75. These are the instructions given in the beginning, and you have to follow this. Question number 1. Solve the inequality 2x minus 1 modulus is less than 3x plus 1 modulus. So since there is a modulus on both sides, so there will be an equation of the line in the beginning you should know. And that will be equal to 2x minus 1 whole square, then square root, is less than 3 into x plus 1 whole square root. So taking the square on both sides, this will become 2x minus 1 whole square is less than 9 into x plus 1 whole square. Now you open it, 4x square minus 4x plus 1 is less than 9 into x square plus 2x plus 1. This will become 4x square minus 4x plus 1 is less than 9x square plus 18x plus 9. Shifting it on one side, 9x square minus 4x square is 5x square plus 18x minus 4x plus 22x, and plus 9 minus 1 is plus 8. So it should be equal to 5x square plus 22x plus 8 is greater than 0. Now you will find the critical solution. That means 5x square plus 22x plus 8 equal to 0. 5 8s are 40, and that's 5x square by splitting parts, 20x plus 2x plus 8 equal to 0. Here 5x is common. It should be equal to x plus 4, plus 2 is common. It should be equal to x plus 4 equal to 0, or x plus 4 into 5x plus 2 equal to 0. So x value is minus 4 and minus 2 by 5. So we will represent it on the system. So it is minus 4 and it is minus 2 by 5. Since the coefficient of x square is positive, so it should be minima there. And now we need the greater than 0. That means what? Positive values. So here the positive values are before this minus 4 and after this minus 2 by 5. So our required answer for this inequality is x less than minus 4 or x greater than minus 2 by 5. On the sketch of this Argand diagram, shade the region whose points represents the complex number z satisfying this inequality. Z plus 1 minus iota modulus is less than or equal to 1, and argument of z minus 1 is less than or equal to 3 pi by 4. So first it is z plus 1 minus iota is less than or equal to 1, because there is modulus on one side, this constant number is on the other side, so they will be representing a circle there. So it should be equal to x plus iota by plus 1 minus iota is less than or equal to 1, or x plus 1 plus iota into y minus 1 whole modulus is less than or equal to 1, or x plus 1 whole square plus y minus 1 whole square root is less than or equal to 1, or it is equal to x plus 1 whole square plus y minus 1 whole square is less than or equal to 1. So the center of this line is minus 1 and 1, and the radius of this one is equal to 1. So it is minus 1 and 1. So this is the center, and the radius is equal to 1. So it is representing a circle there. which is less than or equal to 1. So all outside the region is shaded. So this is inside the region is the required part of it. And the second part of this one is argument of z minus 1 is less than or equal to 3 pi by 4. Argument word is as it is. Z is x plus iota y minus 1 is less than 3 pi by 4. Now we know that it will become theta, that is equal to tangent inverse of imaginary component is y and the real component is x minus 1 is less than or equal to 3 pi by 4, or y over x minus 1 is less than or equal to tangent of 3 pi by 4. So y over x minus 1 is less than or equal to minus 1, or y is less than or equal to minus x plus 1, and this is y-intercept is minus 1, the slope is negative. So it is a graph like this. And because it is less than, this portion will be shaded and the lower part is the required region of this. So you have to represent it on both the same lines. This is x-axis, this is y-axis, this is minus 1, this is plus 1. And the second one is y is greater than equal to 1. So this is shaded part is the required answer of this inequality there. The variables x and y satisfy this equation. X is equal to a into y 3 power minus y, where a is a constant. Explain why the gradient of this y against log of x is a straight line, and state the exact value of this gradient of this line there. Since y is equal to, since x is equal to a into 3 power minus y, we take whenever the variable is in power, so you have to take the log on both sides. So we take the log on both sides. So log of x is equal to log of a into 3 power minus y. This one is as log of x is equal to log of a plus log of 3 power minus y. Or this will become log of x is equal to log of a minus y log of 3. Or log of x is equal to log of a minus y log of 3, or y log of 3 is equal to log of a minus log of x, or y is equal to log of a over 3 minus log of x over 3. Let's say it is 1. We know the standard equation of this one is y is equal to mx plus c, where y is equal to y and m is equal to minus 1 and x is equal to log of x. So that is why it is representing a straight line there. Now they are asking also there, state the exact value of the gradient of this line. So gradient of this line is basically equal to minus log of 3. So that is minus log of 3 value is equal to 1 point. Total value is equal to minus 0 point. So this is the gradient of that line there. Can you see? It is given that the line intersects the y-axis at the point y is equal to 1.3. Calculate the value of a, give your answer to the two decimal places. So we have calculated the value of m there, that is minus 1.9, and y is equal to mx plus c. So you can put the values into this. Intersects the y-axis at the point where y is equal to 1 over 3. So 1.3 is equal to, as y is equal to mx plus c. So y is equal to, so the point is x is 0 and y value is 1.3. So 1.3 is equal to m into 0 plus c. So c value is basically equal to 1.3. And the value of a, c value is basically equal to log of a over minus log of a over log of 3. So y is equal to mx plus c. Y value is 1.3. M value is minus क्या था is 0 log of a over, it is plus or minus, minus plus log of plus a. So 1.3 is equal to log of a over log of 3. So log of a is equal to 1.3 log of 3. So that value is equal to 1 point. So a value is anti-log of 1.428. So that value is equal to 4 point. So this is the value of a there. Now, using this integration by parts, find the exact value of tangent inverse of half x d of x. So integration from 0 to 2 tangent inverse of half x d of x. This by integration by parts is v du by dx into d of x is equal to uv minus u dv by dx into d of x. But there's only one function shown in this part. So we can multiply this portion as 0 to 2, 1 into tangent inverse of half x d of x. Now we take it as du by dx is equal to 1. So u is equal to x and v is equal to tangent inverse of half x. So dv by dx for this portion is 1 plus 1 over 2x whole square over into the derivative of this one is half. X is half there. So it should be equal to dv over dx is basically equal to half into 1 over 4 plus x square over 4. So that is equal to 2 over 4 plus x square. So now we put it into this equation. So that should be equal to u, and u there is equal to x into v. That is tangent inverse of half x minus integration of x into the derivative of this one is 4 over 4 plus x square. So it is 2 over x square into d of x. So this will become equal to x tangent inverse of half x. So minus, sorry, 2x over 4 plus x square d of x. So that thing is equal to x tangent inverse of x over 2 minus, because the derivative of this 4 plus x square derivative is 2x. So it should be equal to minus log of 4 plus x square. And because the parameters are 0 to 2. So this is the whole integration of this portion. And now you put the upper limit and then minus the lower limit. So it should be equal to 2 tangent inverse of 2 over 2 minus log of 4 plus 4 minus 0 into anything is 0 minus log of 0 plus 4 is 4. So that should be equal to 2 tangent inverse of 1 minus log of 8 minus minus plus log of 4. But tangent inverse of 1 is pi by 4. So 2 into pi by 4 minus log of 8 plus log of 4. Plus log of 2, because 4 over 8 is 1 over 2. Question number 5. The complex numbers u is given by u is equal to 10 minus 4 root 6 iota. Find the two square roots of this u, giving your answer in this form of a plus iota b in the form of the real and the exact values. Because it is plus log of 4 minus log of 8. So we are going to divide it like this. So it should be equal to 1 by 2 log of 1 minus log of 2. So it should be equal to plus, and it should be equal to pi by 2 minus log of 2. U is given by this 10 minus 4 6 iota. Find these two square roots of this u, giving your answer in this form of this a plus iota b, where a and b are the real and the imaginary. So you are going to find out the u square root. So that is equal to 10 minus 4 root 6 iota square root. That thing you are going to find out. But we know that the square root of a complex number is always a complex number. So it should be equal to 10 minus 4 root 6 iota square root is equal to x plus iota y or a plus iota b. Now taking the square on both sides, so it should be equal to 10 minus 4 root 6 iota whole square is equal to a square plus iota square b square plus 2 iota ab, or 10 minus 4 root 6 iota is equal to a square minus b square plus 2 iota ab. Let's say it is equation number 1. Now comparing real parts, it is 10, and that thing is equal to a square minus b square. Taking the imaginary parts, it is minus 4 root 6 is equal to 2ab, or b is equal to minus 4 root 6 over 2a, or that is equal to minus 2 root 6 over b. Now we put it into this equation 2. So 10 is equal to a square and b is equal to minus 2 root over a. So that is minus 2 root 6 over a whole square. So this should be equal to 10 is equal to a square. So that is equal to 4 to 6, 24 over a square. This will become, taking LCM, 10 is equal to a4 minus 24 over a square. This will become a4 minus 24 is equal to 10a square, or a4 minus 24 minus 10a square is equal to 0, or it will become a4 minus 10a square minus 24 square is equal to 0. Let a square is equal to p, and that is equal to, then square 4 is equal to p square. So this will become p square minus 10p minus 24 is equal to 0. Hmm? Yeah. So it should be equal to p square minus 12p plus 2p minus 24 is equal to 0. P is common, p minus 12 plus 2 is common, p minus 12 equal to 0, or p minus 12 into p plus 2 equal to 0. So p value is equal to 12 or minus 2, but p is equal to a square. So this implies that a square is equal to 12. Then a value is equal to square root of 12. That is 2 root 3 positive negative. And if p is equal to a square is equal to minus 2, which is not acceptable because it is negative sign there and a is a real quantity, so it should not be possible. So a value is only plus minus 2 root 3 there. So when a is equal to plus minus 2 root 3, then b value is minus 2 root 6 over a. So that is minus 2 root 6 over plus minus 2 root 3 So that is plus minus 2 there. So A value is finally written as A plus iota B. So if A is 2 root 3 plus iota, then B value is negative. So 2 root 3 minus 2 root iota. Iota is not there. Two root 3 minus 2 iota. Root 2 iota. Or the other value is there. If it is negative, minus 2 root 3, then it is plus iota plus 2 root. So it should be equal to minus 2 root 3 plus 2 root iota. So these are the two square roots of this number there. Question number 6 now. Prove that cosecant 2 theta minus cotangent 2 theta is equal to tangent theta. So this should be written in the form of 1 over sine of 2 theta minus cos 2 theta over sine 2 theta. Let's say it is the left hand side of this option. So that should be equal to sine 2 theta is the LCM. So it should be equal to 1 minus cos of 2 theta. Now 1 minus cos 2 theta is basically equal to 2 cos square theta minus 1 over sine 2 theta is 2 sine theta cos theta. Or this should be equal to 1 minus 2 cos square theta plus 1 over 2 sine theta cos theta, which is equal to 2 minus 2 cos square theta over 2 sine theta cos theta. Sorry. This will be equal to 2 common 1 minus cos square theta over 2 sine theta cos theta. But 1 minus cos square theta is equal to sine square theta over sine theta into cos theta. That is equal to sine theta over cos theta, and that is equal to tangent square theta, which is the right hand side of this expression. Hence, show that the integral from pi by 4 to pi by 3 cosecant 2 theta minus cotangent 2 theta d theta is equal to half log of 2. Since pi by 4 to pi by 3 cosecant 2 theta minus cotangent 2 theta, we have proved it that it is basically equal to tangent theta into d theta, as cosecant 2 theta minus cotangent 2 theta is equal to tangent theta. That thing we have proved. So this will become pi by 4 to pi by 3. It is sine theta over cos theta into d theta. But we know that if function is in the denominator, the derivative is in the numerator, then it is equal to log of f of x d of x. But cos theta derivative is minus sine theta, so you take minus sine is outside there. So it should be equal to minus log of cos theta, and the limit there is pi by 4 to pi by 3. So we can change the limits now. So it should be equal to log of cos theta, and it will be equal to pi by 3 to pi by 4. So this should be equal to log of cos of pi by 4 minus log of cos of pi by 3. So log of pi by 4 is cos of pi by 4 is 1 over root 2 minus log 60 is 1 over 2. So it should be equal to log of 1 minus log of 2 minus log of 1 plus log of 2. Log of 1 minus log of square root of 2 minus log of 1 minus minus plus log of 2. So log of 1 and log of 1 cancel out. It should be equal to minus 1 over 2 log of 2 plus log of 2. So that is equal to half log of 2. Now, a curve is such that the gradient at the general point with the coordinates x, y is proportional to y over x plus 1 square root. The curve passes from the point with the coordinates 0, 1, and 3 and e. By satisfying this up and solving this differential equation, find the exact of the curve expressing y in terms of x there. Since xy is proportional to, so here the word is what proportional to, so we can use this word that dy by dx is proportional to y over x plus 1 square root. So this will become dy by dx is equal to, proportional sign will be changed to the equality sign, ky over x plus 1 square root. Let's say it is equation number 1. Since it passes from this point 0, 1, so it passes from this point 0, 1, and the other point is 3 and e there. So you are going to find out this equation in terms of y, in terms of x, you are going to express it. So we will separate that equation in terms of this variable dy over y is equal to k into dx over x plus 1 square root. So by taking the integration sign on both, so this will become there using the same log formula there. So log of y is equal to, just a minute. So function is in denominator, derivative is in the numerator, then it should be equal to log of f of x, and the other is the integration of x power minus half d of x is equal to 2 into x plus 1 half. Now we put into this all, so it should be equal to log of y is equal to k constant as it is into 1 over x plus 1 square root is basically equal to 2 into x plus 1 power half plus constant of integration a there. Now we are going to put these two conditions into this part. First of all, one condition is that A is passing from the point 0, 1. So log of 1 is equal to K into 2 into X is 0 there. Log of 1 is 0. 2K into 1 is 1 plus A. Our A value is equal to, now for the second condition we are going to put log of E is equal to K into 2 into 3 plus 1 power half plus A. So log of E is equal to 1, that is equal to 2K, 3 plus 1 is 4, 4 power half is 2 plus A. So it should be equal to 1 is equal to 4K plus A, but A value is being calculated there minus 2K. So 1 is equal to 4K minus 2K, or 2K is equal to 1. This implies that K is equal to 1 over 2. Then A value will be equal to minus 2K. So minus 2 into half, that is equal to minus 1. So A value is minus 1 and K value is equal to half. So we put into this main equation there that log of y is equal to K value is half into 2. That's being cancelled out. K x plus 1 power half and A value is minus 1. Now, this we can have to combine. Log of y is equal to x plus 1 power half minus log of e, because log of e is equal to 1. So you can write this thing as log of y plus log of e is equal to x plus 1 power half, or log of ye is equal to x plus 1 power half. Now taking anti-log on both sides, ye is equal to e power x plus 1 power half, or y is equal to e power x plus 1 power half over e. This e can be shifted to this numerator there. So it should be equal to e power x plus half minus 1. Or it should be equal to x minus half there. Okay. Question number 8 now. The equation of this curve is y is equal to e power minus 5x tangent square of x, where x lies between minus pi by 2 to plus pi by 2. Find the x coordinate of the stationary point of this curve, giving your answer to the 3 decimal places where appropriate. So since y is equal to e power minus 5x tangent square of x, where x lies between minus pi by 2 to plus pi by 2. And you have to find out the x coordinate of the stationary point. That means what, dy by dx is equal to 0. So dy by dx is equal to, let's say this is u and this one is v. So that is tangent square of x as it is into the derivative of this is minus 5 e power minus 5x plus e power minus 5x as it is into tangent square x, that is 2 tangent of x. Then without power, tangent x derivative is secant square of x, and x derivative is 1. And that should be equal to 0. So it should be equal to minus 5 e power minus 5 of x tangent square of x plus 2 e power minus 5x tangent of x into secant square of x, and that is equal to 0. And now we can change that secant square of x in the form of tangent of x there. So it should be equal to minus 5 e power minus 5 of x tangent square of x plus 2 e power minus 5 of x into tangent of x, and secant square x is equal to 1 plus tangent square of x, and that thing is equal to 0. So this will be equal to minus 5 e power minus 5x tangent square of x plus 2 e power minus 5x tangent of x plus 2 e power minus 5x tan cube of x equal to 0. Now you can take e power minus 5x is common, and tangent of x is common there. So you can write this thing as e power minus 5 of x into tangent of x is common there. So it should be equal to minus 5 into tan of x plus 2. This thing is already being common there, plus 2 tan square of x, and that thing is equal to 0. So either e power minus 5 of x tangent of x equal to 0, or minus 5 tangent of x plus 2 tangent square of x is equal to 0. But if it is 0, then e power minus 5x cannot be equal to 0. Then tangent of x equal to 0, then x is equal to tangent inverse of 0, that is equal to 0 or pi. But both values are not in the part of this answer, so they will be rejected there. Then minus 5 tangent of x plus 2 tan square of x is equal to 0. Let tangent of x is equal to p, tangent square of x is equal to p square. Then we can find out this one as 2p square minus 5p plus 2 equal to 0, or 2p square minus 4p minus p plus 2 equal to 0. 2p is common, p minus 2 minus 1 is common, p minus 2 equal to 0, or p minus 2 into 2p minus 1 equal to 0, p is equal to 2, and p is equal to half. But p itself equal to tangent of x equal to 2, then x is equal to tangent inverse of 2, 1.107, because tangent is positive in the first and the last. So one value is 1.07 and the other value is pi plus 1.07. But this value is going to exceed, so this value will not be accepted there. And the pi value is minus pi by 2 to pi by 2. So tangent of x is equal to half, then x is equal to tangent inverse of half, and that value is equal to 4, 6, 4. Another value is pi plus 0.464. So the actual value of x, because x lies between minus pi by 2 to plus pi by 2. So our values is 0 and 464 and 1.07. So these are the actual values which lies in this range of this trigonometric function there. बस ना करिए ये स्टॉप करिए 2 मिनट. Question number 9 now. Let f of x is equal to 14 minus 3x plus 2x square over 2 plus x into 3 plus x square. Express f of x in the partial fraction. Since it is proper fraction because x into x square is x cube and their highest power in the numerator is x square. So it is a proper fraction. So no need to do it into this part. So just we have to write on in the partial fraction of this. So that should be equal to 14 minus 3x plus 2x square over 2 plus x into 3 plus x square is equal to a over 2 plus x, because it is unsolvable quadratic, so it should be equal to bx plus c over 3 plus x square. Let's say it is equation number 1. Then we take the LCM, it should be equal to 14 minus 3x plus 2x square is equal to a into 3 plus x square plus bx plus c into 2 plus x. Now put 2 plus x is equal to 0 for a. So x value is minus 2 in equation number 2. So it should be equal to 14 minus 3 into minus 2 plus 2 into minus 2 square is equal to a into 3 plus minus 2 whole square plus b and c are zeros. So it should be equal to 14 minus plus 6 plus 4 into 4. 8 is equal to a into 3 plus 4 is 7. So 14 plus 6, 20, 28. So a value is 28 over 7. That is equal to 4. For b and c, compare the coefficients. For b and c, compare coefficient of x square and x on both sides. So if we compare the coefficient of x square, then on the left side it should be equal to 2. On the right side it should be equal to a plus 2b plus b. So a value is already calculated equal to this. So b value is equal to 2 minus a. So that is 2 minus 4, that is equal to minus 2. Comparing the coefficient of x on both sides. So x is coefficient is minus 3 on the left side is equal to b plus 2c. b plus c, 2b plus c. So c is equal to minus 3 minus 2. B value is minus 2, 4 minus 3, that is 1. So this expression of f of x is equal to a value is 4 over x plus 2 plus b value is equal to minus 2x plus c value is 1 over x square plus 3. Hence, find the expansion of f of x in ascending power of x up to and including the term of x square. So this will be written as the form of 4 over x plus 2 4 over 2 plus x plus 1 minus 2x 3 plus x square. So this can be written in the form of 4 into 2 is common 1 plus x over 2 plus 1 minus 2x over 3 is common 1 plus x square over 3. And this will be written in the form of 2 into 1 plus x over 2 power minus 1 plus 1 over 3 1 minus 2x into 1 plus x square over 3 power minus 1. By using this binomial theorem, 1 plus x power n is equal to 1 plus nx plus n into n minus 1 over 2 factorial x square and so on, because we are expanding it up till x square. So this should be equal to 2 into 1 plus minus 1 into x over 2 plus minus 1 minus 2 over 2 factorial into x over 2 whole square plus 1 over 3 1 minus 2x into 1 plus minus 1 into x square over 3 plus so on, because here x power 4 will become. So this will become equivalent to 2 into 1 plus 1 minus 1 over x, 1 minus x over 2, this 2 and 2 cancel, so that should be equal to x square over 4 plus 1 over 3, 1 minus x square over 3, then minus 2x, and into this power this is. So this will be equal to 2 minus x plus x square over 2 plus 1 over 3 minus x square over 9 plus minus 2 by 3x. So final answer is equal to 1 by 7 by 3 minus 5x over 3, 7x square over. Question number 10. The diagram shows a trapezium A, B, C, D in which AD and BC is equal to R and AB is equal to 2R. The the acute angles BAD and ABC are equal to x radians. Calculate the arc length. The circular arc of the radius R with the center A and B meets at M, the midpoint of AB. Given that the sum of the arcs of this shaded region is 90% of the area of the trapezium, show that the x satisfies this equation. X is equal to 0.9 into 2 minus cos of x sine of x. Since this is a trapezium as A, B, C, D, we draw a perpendicular from this. We draw a perpendicular from this. So we have to calculate this. Let's say it is E and it is F. So we are going to calculate EF length there, which is equal to DC. But AB, M is the midpoint of AB. It is R. So if we use this triangle AED, where this is R, this is X radian, this is 90 degree. Let's say this length is equal to Y, then Y over R is equal to sine of X, or Y is equal to R sine of X. The same is this length. So Y is equal to R sine of X is this length. Now we will calculate this AE length. Let's say it is equal to K. So K over R is equal to cos of X, or K is equal to R cos of X. So this is basically A to E is R cos of X, and this M to P is also equal to R cos of X. So the total length of this AB is 2R. So MF should be equal to, so EF will be equal to 2R minus 2R cos of X. Now that is equal to BC there. Now we are going to find out the condition according to that. The area of shaded sector. Shaded sector is the two sectors. So that is equal to 2 into half. The radius is there R square into angle between them is X is equal to 90%, that is 90 over 100 of the area of the trapezium. Area of trapezium is basically equal to half into the height of these two sides. Height is basically equal to R sine of X into the sum of the parallel sides. So that is 2R plus EF is basically equal to 2R minus 2R cos of X. So it should be equal to, this 2 and 2 cancel. So it should be equal to R square of X is equal to 0.9. This is 2 into R sine of X into 2 to the 4 R minus 2R cos of X. So it should be equal to 0.9 into half into R sine of X into R is common. So that is equal to 4 minus 2 cos of X. That is equal to R square of X. So it is r and r square cancel out. So x is equal to 0.9 into 1 over 2 sine of x. 2 is common there. It is 2 minus cos of x. So 2 and 2 also cancel out. So x should be equal to 0.9 into sine of x into 2 minus cos of x. And this is the thing we have to prove that now verifying by calculation that x lies between 0.5 and 0.7. So we can write this thing as f of x is equal to x minus 0.9 into sine of x into 2 minus cos of x. So f of 0.5 will be equal to zero point 0.5 minus 0.9 sine of 0.5 into 2 minus cos of 0.5. And this value is equal to 0.57, which is a positive value. Now we will calculate f of 0.7. So it is 0.7 minus 0.9 into sine of 0.7 into 2 minus cos of 0.7, and that value is equal to, since f of 0.5 into f of 0.7 value is less than 0, so the root lies between 0.5 and 0.7, showing if the sequence of this values in this interval from 0 to pi by 2 cos xn plus 1 is equal to cos inverse of 2 minus x power n over 0.9 cos of xn converges the converges to this root of this equation in the part A there. So just remove the subscript. So it will become x is equal to cos inverse of 2 minus x over 0.9. It is cos inverse, sorry, 0.9 into, so it should be equal to sine of x. Now shifting this one to this side, so cos of x is equal to 2 minus x over 0.9 sine of x, or x over 0.9 sine of x is equal to 2 minus cos of x, or x is equal to 0.9 sine of x into 2 minus cos of x. So this is the basic formula to that is being converged to this part. Use this iterative formula to determine x correct to the 2 decimal places. Give the result of each iteration to the 4 decimal places. So our iteration formula there is x n plus 1 is equal to cos inverse of 2 minus x n over 0.9 sine of x n. Since it lies between 0.5 and 0.7, so it should be equal to x1 value will be equal to 0.6. So x2 will be equal to cos inverse of 2 minus x1 over 0.9 of sine of x1, and that value is equal to 0 point, then x3 will be equal to बोलो वही next. So because after two decimal places are required, so x value is equal to 0.61. Question number 11, the last question of this. With respect to the origin O, the points A and B have the position vectors OA is equal to 2i minus j. OB is having this vector j minus 2k 0 1 minus 2. Show that OA and OB are equal and hence use a cross product between this angle AOB. So we are going to find out angle AOB. Let's say that is theta. So we can find out OA, that is already there, 2 minus 1 0. OB there is 1, sorry, 0 1 minus 2. Theta is equal to cos inverse of OA dot OB over OA magnitude into OB magnitude. That is equal to cos inverse of, so 2 into 0 is 0, plus minus 1 into 1 is minus 1, plus 0 into this is 0, divided by 4 plus 1 plus 0 square root into 0 plus 1 plus 4 square root. So that is equal to cos inverse of minus 1 over root 5 and root 5, that is equal to 5, and this value is basically equal to 101.5 degrees. The midpoint of AB is M. The per point P is on the line through O and M is such that PO is ratio OA is equal to 7 ratio 1. Find the possible positions of P. Since AB having the midpoint is M, so let's say that is A, that is B, the midpoint is M. So OM is equal to half of OA plus OB. So that is equal to half of OA is basically equal to OA क्या था? OL for midpoint of AB. 2 plus OB. So OM is basically equal to 2 plus 0, 0, 2 over 2, 1, minus 1 plus 1, 0 over 2, 0, 0 minus 2, minus 2 over 1, minus 1. So OM is basically equal to this 1, 0, minus 1. And now the possible position of P on the line through O and M is such that PA ratio OA is equal to root 7 ratio 1. So M is the midpoint of AB. So AB is equal to OB minus OA. OB is equal to 0, 1 minus 2, 2 minus 1, 0. So that is equal to 0 minus 2 is minus 2, 2 minus 2. So this is your AB, this is your M. Let's say that is O. P is going to lie at this position. So OA plus AM, OA plus AM is basically equal to OM. So OA we already know. So OM is equal to OA is equal to what? 2 minus 1, 0 plus AM. AM is the midpoint of that. That is equal to half of that is what? Half of AP is basically equal to minus 2 minus 1, 0. A, AB, sorry, minus 2 plus 2 minus 2. So it should be equal to 2 minus 1, 0 plus minus 1, 1 minus 1. And that thing is equal to 2 minus 1 is 1, 0 minus 1 minus 0 or 0 plus 1. 0 plus minus 1 minus 1. Now OA plus AM. So that is equal to OM is equal to OM is basically equal to minus 1, 0 and minus 1. Now, because it's going to lie on this line of this P is going to lie on O and M there. So the equation of this line L is equal to O, that is 0, 0, 0 plus lambda times AB OP, that is equal to 1, 0 minus 1. So it should be equal to lambda 0 minus lambda. Now, there. So we are going to find out this values of PA. Now PA is basically equal to OA minus OP. OA is basically equal to 2 minus 1, 0 minus OP is we have lambda 0 minus lambda. So it should be equal to 2 minus lambda minus 1 and lambda. Now PA ratio OA is equal to 7 ratio 1. So PA is basically equal to 2 minus lambda square plus minus 1 square plus lambda square whole square root ratio OA is 4 plus 1 plus 0 is equal to root 7 ratio 1. Okay, sir? So it should be equal to taking the square on both sides. 2 minus lambda square plus 1 plus lambda square is equal to ratio 4 plus 1 is 5 is equal to root 7 ratio 1. So the square of this one is so it should be equal to 2 minus lambda square plus 1 plus lambda square is equal to sorry ratio 5 is equal to 7 ratio 1. So now we just 2 minus lambda square plus 1 plus lambda square over 5 is equal to 7 over 1. Or this will become 2 minus lambda square plus 1 plus lambda square is equal to 35. Or 4 minus 4 lambda plus lambda square plus 1 plus lambda square is equal to 35. Or 2 lambda square minus 4 lambda plus 4 plus 1 is 5, 35. So minus 30 is equal to 0. Or lambda square minus 2 lambda minus 15 equal to 0. Or lambda square minus 5 lambda plus 3 lambda minus 15 equal to 0. Lambda minus 5 into lambda plus 3 equal to 0. So lambda is equal to 5 and minus 3. But the OP position is lambda 0 minus lambda. So if you take lambda is equal to 5, then the possible position of this one is 5, 0 minus 5. Or it would be equal to 5i plus 0j plus minus 5k. And if OP is equal to same lambda 0 minus lambda, where lambda is equal to minus 3, then it should be equal to minus 303. So it should be equal to minus 3i plus 0j plus 3k. So these are the two possible positions of this point P on this